9.6, we have these quadratics or whatever, 9.6 or whatever problem. And they are, you'll notice there's a lot of x squared still showing up. So in problem one, you have a bungee jumper jumps off of a cliff or whatever they do. And it says we can model this, the height of that bungee jumper by this, as it compares to the time going by. And so they say h, or the height, equals -16 times the time in seconds squared plus 200. And don't feel like you have to know where they're getting the 16 or the 200 from. It really is, these are physics applications. Nobody expects you to know how to model that or anything. They're always going to give you some weird equation to work with. And so, but what they're asking you is, they say something like, they give you this, equation that models the deal, where it's saying as time goes by, the height is going to change. How high above the ground are you is what it's saying. And so, the picture is, here's, I don't know, here's this guy jumping, and it'll be like, if he starts way up here, which secretly is 200 feet, is where they're getting that 200. He starts at 200 feet tall, so he's at his 200-foot tall cliff or building or whatever it is. He jumps. And of course, as more time goes by, well, his height is getting less and less. Right here, he's at 200 feet high, then he's at 150, then he's at 100, and then he's at 50, and then he's at 0 feet high at some point. And that means as time goes by, as more seconds go by, and he's just looking at his watch on the way down, and of course, at some point, the bungee cord actually catches him and it changes these things, whatever. But anyway, as time goes by, he's going further and further down. So more seconds going by is less and less height, and so you'd expect for that, the height to be less and less over time, because he is, he's a lot lower as he drops, of course. And so they're saying things like, well, find his height after some number of seconds. They ask you for 1 second and 3 seconds. So you can practice that. I'm going to go ahead and do 2 seconds, which will give an answer kind of in between those two. After 2 seconds, what is his height? What is his height? Pretend like I wrote that. What is his height after 2 seconds? Question mark. And so for that kind of thing, we're just going to plug in 2 seconds into the time thing, because of course seconds are a time thing. And so we'll say, what is his height? Please work. Okay, just it says height. What is his height? If we have 2 seconds of time going by, we'll say -16, and then I'll put a 2 for time. Squared plus 200. My cool cursive 200. And then, we're running numbers. Just be careful. Remember, we're going to square things first before we times by the 16. So it's not 16 times 2. We'll keep the 16 for a second, and we'll do the 2 squared, of course, which is 4. And then plus 200. Come on. And then doing the thing. And so then 16 times 4, I know that one is -64. Well, I didn't write a 64. There we go. -64 plus 200. And then we're just doing the left and the right. That's -64, positive 200. Kind of like 200 take away 64, I think is 136. So at 2 seconds time, he's at 136 feet in the air. Is what we're looking at. So that's how number one kind of goes on both part A and B. And then on number 2, okay. Number 2, we have, oh yeah, it's this gamer, whatever, is making it and selling games. And they tell you that the sales that they're getting, the number of dollars in sales, come on, the number of dollars in sales they're getting varies by the price, of course, and that makes sense, don't feel like you have to make sense of the equation again. This is, pretty intense, as they call it, mathematical modeling. Okay, -64 t squared plus 1600. Oh no, it's not t, it's a p for price there. So let me take a second. P squared. Okay, plus 1600 times p, where p is the price, And so what they're suggesting is that if you charge different amounts of money or different prices, of course your sales are going to go up or down accordingly. And so here, as an aside real quick, don't feel like you have to write this part down. It's not part of the question, but it'll help make sense of a little bit of this without you having to know all the details of it. And so if we were to say, like, keep track of your prices and watch how the sales go, I'll go ahead and put a $, but, it's like S for sales at the same time, You'd figure if you charge too small a price, like if I plug in a 0 or a 1 or something for $1 a price or $2 for a price on a video game, I might sell a whole ton of copies of it. But that doesn't mean that my sales are high because I'm not making much money on any given one. If I only sell my games for $1 each, well, okay, I've sold 50 of them, but I only made $50, you know? And so what we find is that if the price is too small, the sales are small. And so you're getting small amounts and you're like, well, okay, it's good to have a low price, but at some point it's bad. And so then you start charging more and more and more and thinking about, okay, yeah, as I'm charging more, I'm getting more money in. Each time I sell the video game, I'm getting like, $40, $50 each now. And it's good because now I'm still selling a pretty good amount of them. But at some point, of course, if your price gets too high, if you get a way too high up their price, then people will start buying it less. You won't get very many sales. And then at this point, you're like, well, I'm raking in $100 on each game and $200 on each game, but you're only selling like once a month, or something like that. And at some point, your price, if it gets too high, if you have a price that's too far over, you're charging $200 for a game, you're going to get zero sales. And all of a sudden, your higher price idea is working against you for obvious reasons. Nobody wants to buy it. And so what you see is this quadratic model going on again. And so that's where this junk kind of comes from. And this is, I wanted to help you to make sense of why the application goes the way it goes. Because if you plug in certain prices, it would seem, of course, well, okay, you charge more, you make more. But we know that's not the case. If you charge too much, you're not going to make enough. And if you charge too little, you don't even have potential to make enough money, even if you're selling a lot. So that's what's going on with this. And this application, let's see here. Yeah, they're looking to maximize sales. We're going to be focusing on the vertex here. And so if we're looking at sort of what's going to go on, and don't feel like these dots are associated with that equation, but the idea is that we're going to look at the x value or the p value, in this case, the x value of the vertex there, using a negative b over 2a thing. And then that'll tell us what price maximizes the sales. And then, of course, the y value of that will tell you how high the sales are at that time. I say, of course, that's not obvious. Anyway, without yakking a whole bunch, we'd say, oh yeah, their question was, what price? Oh yeah. So then for part A, they say, what price will maximize the sale? What price maximize the sales? And by the way, just if you're taking notes, there's a quiz question about this, and it's saying, and they'll ask you something about a similar question. They'll say, well, what do I do to figure out the maximum thing? And so on that, all you really have to tell them is you don't have to, in the quiz, you don't have to even run numbers on that question. You just have to tell them, well, what I'm looking for is the x value of the vertex, and that will help me to maximize my sales. Pretend like it says vertex. There we go. And that'll help me to maximize my sales. And so that actually comes up in the quiz in a way that you don't have to run numbers. There's a couple of questions like that where there's asking things. Matter of fact, let's talk about that too. There's 2 questions that come to mind out of 5-question quiz. One of them will ask you about that, and he'll say, well, what am I looking for when I'm trying to maximize? And you're going to say, I'm looking for the x value of the vertex, because that's going to tell me what input drives me to the maximum value, whether it's talking about sales or whatever else. And then another thing they will ask you about is, okay, if I have a quadratic model situation like this one, well, if I'm thinking about A and B and C and A to B over 2A and all these things, one thing that's definitely true is that my A value, if we were to talk about like this is the A and the B, and there's no C term here, I guess the C would be 0 or something like that, so that would be a C. Is one thing that we notice with quadratics like this is that, it's an upside down one. It goes up, it has a maximum value, and then it comes back down. So any quadratic that has a maximum value or, it tops out, it has a negative A value, as you know, because of course, if the A term, if the 64 were positive, we'd have this kind of a parabola, and so that's one thing to watch out for. It's one of those, which one is true or which is not true, actually, is the way they phrase it. And so one thing you have to watch out for is, remember, yes, the the A value should be negative. So they say something like, well, the vertex, the A value of your parabola should be positive. Well, that's not true, you know. So watch out for that. A value should be positive, not true. A value positive. No, that's not the case. And so watch out for that. Wanted to mention that. I know that's not homework stuff, but it's weird. There's weird questions in your quiz, and I wanted to bring it up. Okay. As it were, pretend like I erased all that pretty well. Okay. And then I wanted to talk to you about this other, oh yeah, the rest of this question. Okay, so what price will maximize the sales? Well, that's where we're like, well, I don't know what number to plug in for the price now. You know, they're not telling me a particular price to plug in. They're telling me to figure out which one will maximize the sales. And to maximize sales means I want to have the biggest output number possible. So you could just plug in a bunch of numbers for the price and see which one eventually gives you the highest output. You know, but what we normally do is, you'll remember, to find a vertex values, we'll say, well, the X value, or in this case, I'll write X above it, but really it's the P value, or the price value here, is equal to the negative B over the 2A. It's kind of our cheater's way of finding a vertex, if you'll remember. And so then we'll be like A, B, and C. And so then the B value is 1600. So negative B would be a negative 1600 over 2 times A, which is 2 times of negative 64. Again, that was our cheater's way out, but it seems to be working. And then let's see, I had 1600 over 2 times 64 should be 128. That's also negative 128. The negatives will cancel, and that's nice. And then you just, I don't know how many times 128 goes into 1600. That is 128, right? Okay, so then 16, I'm doing it on the calculator, divided by 128. Looks like 12.5. 12.5. But what that means in dollars, and you know, in a money application here, we have what price is maximizing sales. It's $12.5, or 12.5, of course, in dollars. Oh my goodness. Penmanship award for $12.5 is $12.50, if you will. It's $12.50. And so that'll be the price that maximizes it. Now for part B of that same thing, they're asking you, well, okay, what are the maximum sales at that time? So, you know, kind of back to our diagram here, we were finding that a middle price, you know, not a price that's too low or too high, but a medium price. Turns out the best price in his situation is $12.50. And so, but then the other question is, well, okay, once you found the sweet spot, how high up are those sales, you know? And so what we do in that case is we'll take our 12.5 and we'll plug it into the price like we were doing, and then we'll see what the output sales are. And so let's do that real quick. I'll do it on a new slide. Okay, so in this case, we found out, okay, we're like sales is equal to negative 64. I keep putting the 16. Okay, negative 64 times the price squared plus $1,600, or plus 1,600 times P. Okay, and then we found out the price that maximized this, that optimized it, was $12.50. So we're going to plug in 12.5 in both of those prices and then see what the output is. So negative 64, why with the 16 thing? Negative 64, and then P is 12.5 for the price squared. Plus 16, oh my goodness, there we go. 1,600 times the price again. And again, don't feel like you have to know how they came up with it. Like it's, you know, it takes a lot of skill to know where the equation comes from. And then we're just gonna like shoot the numbers through, and then, you know, yada, yada. Watch out as you do that, of course, because this is a negative number. And so I won't run the numbers on this one, but I'll let you finish it. The idea is, of course, we'll do 12.5 squared, so that'd be 12.5 times another 12.5. And then times that by negative 64, what that'll end up being is a big negative number. And then, of course, then you'll times these two. You have 1,600 times 12.5. That'll be a big number, and it's positive. So we'll have a big negative here and a big positive there, and it's a left and it's a right. And actually, if I remember right, these come out to pretty good numbers. And so don't be shocked if the decimal goes away and you have like a bunch of zeros. I believe it does come out to like 10,000, 20,000, stuff like that, you know. Anyway, and then what you left and your right, and then you got some, the sales will be some amount of dollars that you come up with here, and it'll be a pretty good sized chunk. Sales in dollars, there'll be some number there. Okay, and then number 3. Let's see it. Okay, 3 is back to an object in the air, kind of like the bungee jumper. You have a ball being thrown. So now we have the height given for the ball being thrown, and it looks similar to the first application with a little bit of other complication. We have negative 16 t squared plus 48t, and then plus something. Oh, we got plus 4. And again, don't. It came up for the idea is that this thing was thrown from somebody's arm was 4 feet in the air or something, and they threw it at 48 feet per second is how fast they threw it. And this has to do with the same falling thing as the bungee jumping guy. It doesn't really matter. Okay, but what they ask you is think different kinds of questions. If they were to ask you, well, what's the height after a certain number of seconds? Well, we just plug in for time again. But this time they're asking you about a maximum height and things like this. And so remember, for A, B, and C. Okay, let's see here. Okay, for part A, they're saying, well, how many seconds until it reaches the maximum height? That's just like the last problem where we're looking for a maximum value. Seconds to reach max height. Whoa. And so remember how that goes. For a maximum height, if you're looking for a maximum or a minimum in a quadratic here, we're looking for the vertex. So this will be the x value of the vertex. In part B, we'll probably plug in to get the y value. So then seconds to reach the max height. Well, here we go. We're going to do like we do. It's the x, or you could say t, I guess, the time that it takes to get there is negative b over 2a again, is our cheater shortcut out of that. And then that'll be negative b is negative 48. This is our a and our b and our c. Negative 48 over 2 times the a number is negative 16. And then we're watching the numbers roll, and blah, 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 and it'll give you something in the end. The negatives will cancel because this will be negative 2. So like negative 48 over negative 32, something 0.5 or 0.25, I don't know. Anyway, that'll be a number of seconds. And then for part B, it'll be just like on the last one. Now you're going to plug that number in. And so then it'll be essentially just h equals negative 16. And then whatever number you got here, whatever your answer was there, you plug it in for the time squared plus 48 times some amount of that same amount of time plus 4. And that'll give you a height output, and you just run those numbers again. Make sure you square first before you do the times 16 and stuff. Things like that. And so that'll give you a maximum height. But then, okay, so those kinds of things, let me know if it gives you trouble, of course, but it'll be similar to question number 2. That doesn't mean it'll be easy. They're very easy to mess up. So take your time on it. Take plenty of time on it. Watch the negatives, all these things, and look back at everything. I go through this stuff as though, I'm trying to keep the video short, as though it's just like, oh, everything is obvious here, but it's not. It's very easy to mess up, as you know. And so, be very careful with it best you can. Anyway, for part C of that same question, this is sort of a newer situation. Nothing that you haven't seen algebraically before. But in applications, what they're asking is, when does it hit the ground? When does this thing, it's the ball in the air, when does the ball hit the ground? Or when I say when, they're going to phrase it a little more precisely, probably something like, after how many seconds does it hit the ground? And so if we remember the equation, of course, is the height of the ball is given with respect to the time in seconds that have gone by. Time squared and 48. The time in seconds plus 4. Okay. If we have that, when they say, well, when does it hit the ground, or after how many seconds does it hit the ground, we're trying to reverse engineer and figure out, well, what number could I plug in for the t's here so that the height then is on the ground, which is 0 feet high, And so, insight about that, of course, is we're looking for how to make this thing 0 feet high. And so in that case, we'll actually just plug it in backwards, and we'll say, I'm going to plug in for a height now. What makes the height 0? And so we'll say negative 16t squared plus 48t plus 4. Don't let your t's look like your pluses. And then equal that to 0. And then to figure that out, looks like my battery's running out, so I'll have to be fast. To figure that out, we'll have to say, well, this is back to A and B and C and doing the quadratic formula thing again. And we have x equals negative a plus or minus square root of b squared minus 4ac all over 2a or whatever. And then we're running numbers like that. And it'll be something to the effect of, let's see, negative b at negative 48 plus or minus the square root of 48 squared minus 4. Wow. Okay, times the a number, and the c number is, what is that? Negative 16. And what's the c number for? Over 2 times the a number is 2 times negative 16. And we're running those. Of course, you'll run the numbers on the inside here. And what you find is that as the plus and the minus, that gives you 2 different answers, as you may remember. But you're really only going to use one of them, because what you find in these applications is, and feel free, by the way, when you get this would be a nasty number that won't square root well. Use your calculator to square root that number, whatever you get inside here. You know, it won't be negative, I think, because you have a minus of an answer that's going to be negative here. Because 4 times negative 16 times 4 will be a negative. So it'll end up being more like a plus in between those, you know. But it will be probably a nasty number. And so probably what I would do is get a calculator out, run the square root of that number, and then do negative 48. Put this up here. After you figure that square root out, do negative 48 plus the number, whatever that weird square root is, some weird number. Divide that answer by, I think this is negative 32. And then if that comes out to be an overall negative answer, then just do it. Well, we have the plus and the minus version. If that gives you an overall negative answer, then forget the plus, just do the minus one. Because I guess what we're watching out for is we can't run into a negative amount of time, you know. They're saying after how many seconds does it hit the ground? And if they said, and you ran the numbers and it came out to -3, well, that means that the ball hits the ground -3 seconds after you kicked it. Or in other words, 3 seconds before or something, you know, it doesn't make sense. And so what we're saying in this case is you have a plus and a minus, run them both and only keep the one that actually works, you know, as a positive answer. Anyway, that's what I got for all that stuff. Let me know how this goes. It's been a while since I've done this, so I gotta remember how to stop the recording here. There it is. Anyway, see you later.